Hi, I'm a tutor in Uplatz. Today we are going to discuss about introduction to C++ programming history and basics. Why is software-based solution most cost-effective to implement functionality in software than hardware? Software bugs easy to fix, give customer new software update. Hardware bugs extremely costly to repair. Customers and old device. And Makefile sensor replacement system increasingly complex, bug unavoidable, allows new features to be added later, implement only up to minimal functionality in hardware to do the rest in software. Software related jobs, many more software jobs than hardware jobs. Relatively small team of hardware designers produce hardware platform like i4. Thousands of companies develop applications for platforms. Only implement directly in hardware when absolutely necessary. Example for performance reasons. Which language to learn? C, C++, Java, Fortran, MATLAB, C Sharp, Objective-C programming languages, popularity, HTTP, www.tiope.com, TIOP is software programming community, index January 2001, all in top 4, Java, C, C++, MATLAB, 23rd, Fortran 27th. Programming language popularity, normalized comparison, HTTP, www.languagepop.com, top 3 languages, C, Java, C++, international standard vendor neutral. C, created by Dennis Ritchie, AT&T Bell Labs in 1970s, international standard ISO, IEC 9899 in 2011, informally known as C11, available on wide range of platforms from microcontrollers to supercomputers. Very few platforms for which not available. Procedural provides language constraints that map efficiently to machine instructions, does not directly support object-oriented generic programming. Application domains, system software, device drivers, embedded applications, application software greatly influence development of C++. When something lost in computer industry for more than 40 years, outliving its creator must be good. C++ created by Parajon Strostrup Bell Labs, originally C with classes, named as C++ in 1983. Most recent specification of language is ISO IEC 14882 2014, known as C++ 14. Procedural, loosely speaking, is superset of C directly supports object-oriented and direct programming, maintains efficiency of C application and domains, system software, application software, device server, embedded software, perform server, client applications, entertainment software such as video games, native code for Android applications greatly influenced development of C# and Java. Java developed in 1990s by James Gosling at Sun Microsystems, later brought by Oracle Corporation, de facto standard, but not international standard usually. Less efficient than C and C++, simplified memory management with garbage collection, direct support for object-oriented programming, application domains, web applications, Android applications. MATLAB, proprietary language developed by the MATLAB, not general purpose programming language. Application domain, numerical computing used to design and simulate system, not used to implement layer 1 systems. Fortran designed by John Batters, IBM in 1950s, international standard ISO IEC 1539 2010, informally known as Fortran 2008. Application domain, scientific and application intensive supercomputing tasks such as weather climate modeling, finite element analysis, computational chemistry. C# developed by Microsoft team led by Anders Egelsberg, ECME 334 and ISO IEC 23270 Most traditional languages now standardized by ECMA or ISO IEC. Intellectual property concerns for Microsoft patterns, object-oriented. Object in C developed by Tom Blau and Brad Cox of Stepstone, later brought by Next and subsequent the Apple, used primarily on Apple Mac OS X and iOS, strict to superset of C. No official standard plan that describes Objective-C authoritative manual on Objective-C 2.5 available from Apple. While on C++, vendor neutral international standard, general purpose, powerful yet efficient, mostly speaking, includes CSO subset. So can learn two languages, C++, C for price of one. Easy to move from C++ to other languages, but often not in the other direction. Many other popular languages inspired by C++. History of C++ motivation developed by Berjani started in 1978 at Computer Science Research Center at Bell Laboratories, Murray, New Jersey, USA. Doctoral work in Computing Laboratory of University of Cambridge, UK. Study alternative for organization of systems for distributed systems. Required development of relatively large and detailed simulated destination B through communication and control distributed computer system based. This is University of Cambridge, UK 1979. In 1979, joined Bell Laboratories after having doctorate work. Started with the attempt to analyze Unix kernel to determine to what extent it could be distributed over a network of computers connected by lab. It a model to module structure of system and pattern of communication between modules. No suitable tools available. Objectives and bad experience writing simulated during PhD studies. Originally used Simula was simulated, later forced to rewrite in BCPL for speed mode, low level than C. BCPL was unable to use. Notion of what properties good and tool would have motivated by these experiences. A suitable tool for projects simulator, operating system, other system programming tasks should support for effective programming organization in Simula, that is classes, some form of class hierarchy, some form of support for concurrencies, strong checking of type system based on classes, produces programs that run fast like with BPCL, be able to easily combine separately compatible units into programs like with BCPL, have simple linkage convention essential for combining units written in languages such as C, Algol, C84 and C. Into single program allow highly portable implementation, only very limited ties to operating system. Timeline for C with classes 1979, 83, May 1979, work on C with classes started. October 1979, initial version of C preprocessor that added similar like classes to C language accessible preprocessor. Later started being referred to as C with classes. March 1990, C pre-purported one real project and several experiments used on about processing system. April 1980, first internal Bell Labs paper on C with classes published later to appear in ACM's SIG plan notices in January 1982. B Strostrup classes and abstract data type facility for C language. Bell Labs Computer Science Technical Award CSTR 84, April 1980. Timeline for C with classes 1983 to 1980 initial, 1980 implementation and the following features: classes, derived classes, public, private, access control, constructors and destructors, call and return functions, call function on implicitly called before every call of every member function, return function implicitly call for every return from every member function, can be used for synchronization and classes, type checking and conversion of function arguments. In 1981, added inline functions, default arguments, overloading of assignment operator. Jan 1982, first general paper on C with classes published. Timeline for C with classes 1783. Part 3. We structure classes and abstracted data representative for the C language. ACM SIG plan notices in 17.1, 42 to 51, Jan 1982. February 1983, more detailed paper on C with classes published. We structure adding classes to C language and exercise in language evolution software practices and experience 32. 161 February 1983. C with classes would very successful generated considerable interest. First real application of C with classes was network simulators. Timeline for C84 and C++ 98, 1982-1988, part 1. Started to work on cleaned up and extended successor to C with classes initially called C84 and later renamed C++. Spring 1982 started work on C front compiler front end for C84, initially written in C with classes and then transcribed to C84. Traditional compiler front end performing complete check of syntax and semantics of language building internal representation of input analyzing and rearranging representation, and finally producing output for some code generator. Generated C code as output. Difficult bootstrap animation with without C84 compiler. The C front software improved special oppressed version of C code. Listening when compiling C front, which could be compared with native C compiler and resulting executable then used to compile C front. Timeline for C84 and C++ 98, 1982, 1998, part 2. December 1983, C84 C with classes renamed C++, named named name used in following paper but in 1983. B stores up data abstraction in C, the lab technical journal 638 1701 1734. October 1984, named C++ suggested Rick Mesh City. In 1983, virtual functions added. Note, going from C with classes to C84 added. Virtual functions name and operator overloading, references constants, CONST, user control, restore memory control, input type checking. January 1984, first C++ manual, B stores of the C++ reference manual, 88 DeepL Labs. Computer Science Technical Report number 108, January 1984, September 1984, paper describing operator overloading published. Timeline for C84 and C++ 98, 1982 to 1988, and part 3, P stores operator overloading in C++ proceeding IFIP WG 2.4 conference on system implementation languages experience and assessment, September 1984. 1984 Stream IO library first and later presented in Stroudsubs and extensible IO facility for C++ in proceedings of summer 1985 used next conference pages 57 to 70 June 1985, February 1985 C from release 5, first session release E for education available to universities, October 1985 C print release 1.0 first commercial release, October 1985 first edition of C++ PM written, B stores of the programming C++ for December 1986. Timeline for C84 and C++ 98, 1982, 1988, and 4. C front release 1.0, 0 correspond to a language defined in this book. October 1985, tutorial paper on C++ B Strauss C++ in the proceedings, the ACM annual conference on the range of computing mid-80s C++ perspective pages 364, October 1985, January 1982, 1986, C front release 1.4, mainly bug fix release, August 1986, first exposition of set of techniques for which C++ was aiming to provide support rather than what features are already implemented and in use. B Stroudsubs, what is object-oriented programming in proceedings of 14th Association of Similar User Conference, Stockholm Street in August 1986. Timeline for C84 and C++ 98, 98, 99, by part 5. September 98, first object-oriented programming systems, languages, and applications. Uppsala conference. As the start of OIP Center on Small Talk. Now, 1986, first commercial C-print, PC4, C-print 1.1, group can spy in Ireland. February 1987, C-print this 1.2, primarily bug fixes, but also added pointers to members, protected members. November 1987, first conference devoted to C++, use Linux C++ conference, Santa Fe, NM, USA. December 1987, first GNU C++ service 1.13. January 1989, first Oregon software, aka Tau Metric C++ release. June 1988, first Zotex C++ release. October 1988, first presented templates at use Nix C++ conference, Delaware, Colorado, USA in paper. B social parameters is types for C++ in procedure and use Nix C++ conference page 1 to 18, Delaware, Colorado, USA, October 1988. October 1988, first you use Nix C++ implemented workshop, ST Park for USA, January 1989. First C++ journal, the C++ report from 6 publications started publishing. In June 1989, a C-print released 2.0 major cleanup new features included multiple integers, type-safe linkage, better resolution of overload functions, better C definition of assignment and initialization, better facilities for user-defined memory management, abstract classes, static member functions, constant member functions, protected member functions first provided in this 1.2 overloading of operator minus greater than pointers to members first provided in this to 1.2. 1988 main features of C-print 2.0 summarized in these stroke steps, the evolution of C++. 1985 to 1980 used Nix computer system to 3 summer. 1988 first presented in stroke steps, the evolution of C++. 1985 to 1987 in proceedings of use Nix C++ conference, pages 1 to 22, Santa Fe, NM, USA. November 1987, November 1989, paper describing exceptions published at A. Koenig and Strokes of exception handling of C++ in proceedings of C++ at World Conference 1989, followed by A. Koenig and B. Strokes of exception handling for C++ in proceedings of use Nix C++ conference, April 1990. December 1989, ANSI X3J60 organizational meeting, Washington, D.C., USA. March 1980, first ANSI X3J16 technical meetings, Somerset, NJ, USA. April 1990, C-print released 2.0, but released to bring C-print mostly into line with ARM. May 1990, annotated reference manual ARM published by M.A. Ellis and source of the annotated C++ reference manual simultaneously. May 1980, formed basis for ANSI standardization. May 1980, first Borland C++, June 1980, templates accepted, Seattle, WUSA, November 1980, exception accepted, Palo Alto, CA 1980. June 1981, second edition of C++ PL published by Strauss of the C++ programming Harrison was second edition, June 1981. June 1981, first ISO WG21 meeting, Lund, Sweden. September 1999, C-print released 2.0 added templates as specified in ARM. October 1999, estimated number of C++ users 100,000. February 1992, first edition DEC DEC C++, including templates and exceptions. March 1992, runtime type identification, RTTA described in Storeshop and the NetGov runtime type identification for C++. The C++ report, March 1992, RTTA in C++ based on this paper. March 1992, first Microsoft C++ did not support templates or exceptions. May 1992, first IBM C++ release, including templates and exceptions. March 1993, RTTA accepted Portland over USA. June 1983, namespace is accepted in January. In 1983, further work on C print release 4.0 abandoned after failed attempt to add exception support. August 1984, ANSI ISO committee draft registered. August 1984, standard template library STL accepted by Waterloo, Ontario, Canada. Described in Stepnow and MD, the standard template library technical report, SPL 9434, R1, SP Lab, August 1994, August 1996, export accepted Stockholm, Sweden. 1997, third edition of C++ PL published by Storstrom, C++ programming language, addition Whitley Longman, reading, MA, USA, third edition, 1997. November 1997, final committee vote on complete standard Morristown NJ, USA, July 1988. Microsoft releases BC++ 6.0. First Microsoft compiler to provide close to complete set of ISO C++. September 1988, ISO IEC 14882 1988, informally known as C++ 98, published. ISO IEC 14882 1988, programming languages C++, September 1988. 1988, Beeman, Dabas, Post provides peer-reviewed portable C++ source libraries. 2000, special edition of C++ PL published by B. Storstrom, the programming C++ programming additionally reading MA, USA special edition, February 2000. April 2001, motion passed to request new work item, technical report on libraries, Copenhagen, Denmark, later to become ISO IEC TR 19768 2007, October 2000, ISO IEC 1488 2003, informally known as C++03, published essentially but fixed releases, no changes to language from programmer's point of view. ISO IEC 14882 2003, programming language C++, October 2003, 2003, work on C++ 0x, known as C++11 stars. October 2004, estimated number of C++ users, 3.27 million. April 2005, first votes on features for C++ OS, Lillehammer, Norway. 2005, auto static asset and R-value reference accepted in principle. April 2005, first full committee official votes on features for C++ 0x Berlin and Marie. September 2006, performance technical report TR 18.15 published. ISO IEC TR 18.15 2006, information technology program language, that environment and system software integrations technical report on C++ performance. September 2006, was by earlier proposal standards. September C++ for embedded system, called embedded C++, or just EC++. EC++ was motivated by performance concern. April 2006, decision to move special mathematical option to separate ISO standard Berlin. Germany team 2 specialists for most programmers. November 2009, ISO IEC TR 19768 2009, known as C++ TR1 published. ISO IEC TR 19768 2009, information technology programming languages, report on C++ library extension, November 2007. Specific series of library extension to be considered for adoption later in C++. 2009, another particularly notable book on C++ published P. Storstrom, Programming Principles and Practices in C++, additionally upper Saddle River, NJ, USA 2009. August 2009, ISO IEC 14882 2011, known as C++ 11, ratified ISO IEC 14882 2011, information technology C++ September 2011. 2013, fourth edition of C++ PL published B. Storstrom, the C++ programming addition with fourth edition 2013. 2014 ISO IEC 44882, 2014 formerly known as C++ 14, ratified ISO IEC 14882, 2014 information programming C++ 2014. Additional commands, reasons for using C as starting point. Flexibility can be used for most application areas. Efficiency, availability, C computers available for most platform. Portability, additional source code relatively portable from one platform to another. Main sources for ideas for C++ aside from C were similar algal 98, BCPL, Clue, ML in particular. Similar game classes, algal 68K operator overloading references, ability to declare variables anywhere in the block. BCPL gave / commands, exception influenced by ML. Templates influenced by generic and parameters in modules in CLU. C++ user population time estimated numbers. October 1979, 1. October 1986, 16. October 1981, 38. October 1982, 85. October 1983, plus 2 CPR recount. October 1981, plus 50, no CPR recount. October 1985, 500. October 1986, 2000. October 1987, 4000. October 1988, 15,000. October 1989, 50,000. October 1919, 1,50,000. October 1991, 4 lakh. October 2004, more than 3.27 million. Above number are conservative. 1979, C++ user processation doubled approximately every 7.5 months. Stable growth thereafter. Success of C++, C++ very successful programming language, not solely because based on C, efficient, provides low-level access to order, but also supports abstraction, non-proprietary in 1980, all rights language transfer standards body, FastANSI and data ISO from 1980, multi-paradigm language supporting procedure, object-oriented, generic, and functional. Example, lambda function programming does not force particular programming, still reasonable, portable, as continued to evolve, incorporating new ideas, example, templates, exception STL, stable, high degree of compatibility with earlier versions of language, very strong bias towards providing general purpose facilities rather than more application specific ones. Application areas, banking and financial, funds transfer, financial lending, teller machines, classical system programming, compilers, operating system, device drivers, network players, editors, database systems, small business application, inventory system, desktop application, document viewers, editors, image editing, embedded system, cameras, cell phones, airplane, medical system appliances, entertainment, game, GUI, hardware design and verification, scientific and numeric computation, physics, engineering, simulation, data analysis, geometric processing, servers, web servers, building system, telecommunication system, phone, networking, monitoring, building on operation systems. Substance evolution of C++, B stores history of C++, 1978 to 1990, and proceedings of ACM history of programming languages conference, pages 298, March 1993. B stores of the design and evolution of C++, edition March 1994. B stores of evolving a language in and for the real world C++, 1991 to 2000, proceedings of ACM and Sigma conference on history of programming languages. Page 414, by 41 to 458, 2007. C-Front software available from Computer History Museum Software Preservation Group, http www.softwarepreservation.org, C http www.softwarepreservation.org, project C++, C-Front, ISO GTC1/SC22/WG21 website, http www.openstd.org, JTC1/SC22/WG21. Standard document ISO IEC 14882/1988, programming languages C++, September 1988, ISO IEC 14882/2003, programming languages C++, 2003, ISO IEC TR 80.15/2006, information technology program languages, their environment and system software. Interfaces technical report on C++ performance 2006, ISO IEC TR 1976A 19768, 2009 Information Technology Programming Language Technical Report on C++ Library Extension, November 2007, ISO IEC 14882, 2011 Information Technology C++ Language, C++ Programming Language, C++, September 2011, ISO IEC 14882, 2014 Information Technology Programming Language, C++, 2014 ISO JTC1/SC22/WD21, website http www.openscd.org/SC22WD21. Building programs, compiling and linking. Allow program, allow CPP include IO string. Init main std : cout allow word \n. Program prints message hello world exclamation and then exit. Starting point for execution of C++ program is function called main. Every C++ program must define function called main. Hash include preprocessor directory to include complete contents of file. IO strip standard a file that defines various types and variables related to IO. std : cout is standard output stream defaults to user's terminal. Operator less than is used for output. Software build process, software code, source code files .cpp.hpp, compile object file.o, source code file .cpp.hpp, compile object code. Then link executable program, start with C++ source code files .cpp.hpp, compile, convert source code to object code stored in object file.o, then compile contents from one or more object files and possibly some libraries to produce executable program. Executable can be run directly. GNU compiler collection, GCC, C++ compiler, G++ command provides both compiling and linking functionality. Command line usage, G++ option input file. Many command line options are supported. Some particularly useful command line options listed on next slide. Compile C++ source file, file cpp.cpp to produce object code file .o. G++ by the C file.cpp link object file. Files file 1.0, file 2.0 to produce executable file executable G++ -o executable file 1.0 file 2.0. The web page http www.gnu.org software GCC. Common G++ command line options: -c compile od, that is do not link. -o file use file for output. -g include debugging information. -on set option of n 0 almost none. 3 full. -std equal to C++ 14 conform to C++ 14 standard. -p thread enable concurrency support via threads library. -idir specify additional directory date to search for include files. -ldar specify additional directory to search for libraries. -lib link with library lib. Pedantic errors strictly enforce compilers in standard. -wall enable most warning messages. -w extra enable some extra warning messages not enabled by wall. -w pedantic one about deviations for strict standard compliance. W error treat all warnings as errors. Manually building allow program, numerous ways in which allow program could be built. Often advantages to compile each source file separately, can compile and link as follows. Compile source code file allow.cpp to produce object file allow.o. G++ -c allow.cpp link object file allow.o to produce executable program allow. G++ -allow.o. Generally, manual building of program is quite tedious, especially when program consists of multiple Source fields and additional compiler options need to be specified. In practice, we use tools to automate build process. That is, example, make utility. Make utility. Make command controls generation of executables and our other non-source files from program source files. Extremely popular tool for automating build process, available on many platforms. Example, Unix, Microsoft Windows, Mac OS X, used extensively on Unix system, very flexible, can handle building multiple programs consisting of hundreds of source files. A single program system, only one source file can be used to build almost anything. There is need not be a program. For example, all materials for this course typeset using LaTeX, example, course pack, slides, exam, and make utility used to compile LaTeX source code into PDF document. One of the most popular implementation of Make is GNU Make. GNU Make webpage, http://www.gnu.org/make. Target is something, make command target is something that can be built typically, but not necessarily files such as executable file or object file. And make command driven by data file called Makefile. Makefile usually named Makefile or Makefile. Command line usage, make option target 0 or more targets to be built. Options 0 or more options. By default looks for Makefile, call Makefile and then Makefile. If no targets are specified, will build first the target specified in Makefile. Only builds files that are not out of date. Most common command line options include -n, show commands that would be executed but do not actually execute them. -f, Makefile, use Makefile, Makefile. Makefile's command starts at hash character, that is hash, and continues until the end of line, semicolon. Example, hash, this command continues until the end of the file. Supports variables and some important variables used by the built-in tools are CXS, C++ compiler command, CXS flags, C++ compiler options, LD flags, linker option to assign value to variable, use equal sign, example CXX equal G++, to substitute value of variable, use $sign followed by variable name in this example dollar within parentheses CXX. Makefiles continued one. Makefile specify targets and rules for building targets. Each rule in Makefile has the following form: targets for the prerequisite commands, indentation shown above must be with a tab character not specified. Targets the stop one or more target. Prerequisite fields on which targets depend. That is files used for to produce targets. Commands actions that must be carried out to produce a target from its prerequisites. Makefiles continue to. Normally, each target associated with file of the same name and building target with create this file. Only target that is not associated with any file. To identify target as phony, make it prerequisite a special character called dot phony example specify all as phony target. Dot phony all. Some special built-in variables that can be used in rules. At target less name of the first prerequisite XR name of all prerequisites separated by spaces. Makefile for allow program CXX is equal to G++ hash the command C++ command compile command C++ CXX flags equal to -G minus capital O hash the compiler C++ compiler options. LD flags is equal to hash the linker option any hash the all target builds all of the programs handled by hash the Makefile the hash this target has this dependency chain hash all to allow CPP all allow hash the clean target removes all of the executable files hash and object files produced by the build process clean rm -f allow star.o and the allow hash allow target builds the allow executable allow allo.o, dollars within brackets CXS, dollar C within brackets CXS flags, finish food, dollar at dollar XR dollar within brackets the flags indicate that the all in targets do not hash correspond to actual fields. Dot 40 colon all clean. The following rules is accepted with it make and therefore need not be explicitly specified. Hash allo.o colon allo.cpp hash dollar C within bracket CXS dollar within bracket CXS plus minus C dollar less. Commentary and Makefile for allo program. All target builds, all of the program handled by the Makefile example allo clean target removes all of the executable files and object files produced by build process. Example allo.o. Although or and clean have no special meaning to make, very common practice to provide targets with these special particular names in all Makefiles. Allo target compiles and the mix the allo program chain of dependencies for all target, all allo.o, allo.cpp, and all and clean examples of pony target. Thank you.